So we'll take out our highlighter. Here is another formula. It is for borrowing money. Okay, the amount borrowed is the present value of the loan. The following relates it to the number of payments. So you're making payments on this. It's similar to the other formula with having an R, the I are the interest rates, compounding periods. But now we can go to our second example here. I'll rewrite that formula out for us. PV equals R square bracket 1 minus Did I get everything right? Are all my brackets in the right spot? Excellent. Oh, and I forgot the negative at the end. Thank you. I didn't quite get it all right. There we go.
Sorry for the interruption. If I could please have our grade 11 students with the last names beginning with the letter A, through to the
So,
letter M,
plugging things in,
to the cafeteria to retrieve your report card. Thank you.
we borrow $15,000. We're making payments of $300. 1 minus 1 plus the interest rate is 0.06 per compounding period, negative n, all divided by 0.06 divided by 12. And what we want to do, we want to get that power by itself. So we're going to need to do some algebra to begin with, to move things over to the other side so we get that by itself. So starting off, what would I like to do first? The 300, the 1, or the 0.06 over 12? If you were simplifying to the other side. What would you do as your first simplification step? This here, what's the opposite of dividing by that? Multiply. If I multiply both sides by 0.06 over 12, these would simplify. And go to my calculator. And I get 75. And next, I divide both sides by 300. Now I don't need those square brackets anymore. What if you like the square brackets? You can have them there for a bit. Now I could subtract the 1 on both sides. Are you okay if I do this? I move that negative over to this side because I'm going to want that power to be positive in the end. And I move the 0.25 over to this side. Okay? Because I want to get the power by itself. And sometimes what people do is they'll subtract 1 and just say, I'm going to just forget about that negative in front. No! You cannot forget about that negative in front. It's still going to be there. So some people will subtract 1 on both sides and then multiply by a negative 1 to get rid of it. But what I did is I just moved this negative term to the left-hand side, moved the 0.25 to the right-hand side. And now I can take the log of both sides. So what does that do? Well, that will bring that exponent of negative n out in front. And now I can get n by itself by dividing by negative log 1 plus 0.06 divided by 12. So I'll go to my calculator, use my fraction button, log 0.75 over negative log 1 plus 0.06 divided by 12. So I've typed it in exactly as I've seen it. I push enter, and I get n is 57.68. So what was I trying to solve for in this question? What was my n? How many monthly payments will the person have to make? So it's a word problem. Write a statement. The person will have to make 58 payments. And even if it came up to be 57.1, you would have to say 58 payments because 57 isn't enough. So scrolling back up, we're now going to do this same question using our TVM solver. So is it all right if I erase the top here? Yes? So if I was using my TVM solver for this to check my work, so this is a nice thing about the TVM solver for these ones. Again, on your exam, you're going to need to show all of your algebra, so what we did first is the important part. But if you're checking your work, now we can plug in everything that we know here. It doesn't matter the order you fill it in, so I always start with, I like interest rate first because it's easy. We're making monthly payments, that's easy. Compounded monthly, that's easy to do. How many monthly payments? So I put a star here with an arrow saying that's what I'm going to solve for. The present value now. You are getting the car. And anytime you get something of value, that goes in as a positive number. So our present value is we owe $15,000. And it's positive because we've got the car. Anytime we get something, it goes in as positive. We're making payments of $300 a month. This will be negative because we're paying. We're taking money out of our pocket and giving it away. Anytime you deposit money somewhere else or give money away or make a payment, that will always be negative. How much will we owe in the future? None. So this will be 0. So this is our setup. We go to our calculator and apps, finance, enter. You can just leave whatever n is what it, like I have 240 in there. I can leave that as is right now. 6% interest, 15,000. We're making $300 payments. The future value will be 0. Now that I have everything in there, I can go to the one that I didn't know. Alpha solve 57.68. So after we've solved this out, and I'll multiply this by 57.68. What will that tell me? Well, if 57.68 was my number of payments, and I'm paying $300 a month, I push enter here, and I find out exactly how much I spent on that car. So I bought a $15,000 car, but I paid $17,304 for it. So that can be significant because now we're paying, we have to say, okay, I realize that because I don't have the money now, I have to pay extra for it. That's the interest that I'm paying to the bank. But I need my car for my job, so that's worth it. Right? You ask yourself, well, what happens I could pay $400 a month. Well, what does that do? So, and this is the fun thing about this program, is instead of having to do a lot of math every time you change one little thing, you get instantaneous answers. So if I do $400 payments and alpha solve, it's only 41.63. So that's just 3.5 years. I'm going to see now, if I multiply this by 41.63, wow, 16,000 instead of 17,000 something. I'm saving $1,000. I'm saving $1,000 by putting a little bit more money each month towards it. So that might be something that affects you. Now, where we see the biggest numbers in loans is not with buying a car, because a car is a big thing and it costs a lot of money, but the biggest thing that you're going to purchase in your lifetime is going to be your house. So we're going to play around with this a little bit now with finding out how much does it cost to buy a house. So we'll take current market right now. I saw a house go up for sale in this area. It was a smaller house, so it would be like kind of the house that you buy when you first buy a house, and its price seemed very reasonable. I think it was just around $200,000, which a lot of houses are going for a lot more than that right now. So you decide, hey, that's perfect. I want to buy this $200,000 house. So what is that going to, how much is that going to cost? Well, first of all, you would be getting $200,000. So your present value would be $200,000. Interest rates right now for houses, well, you probably could find interest rates were as low as 3 a little while ago. They seem to be creeping up. Maybe we'll say you find a mortgage for 3.5%. Okay? Languages of mortgages, one of the languages of mortgages is how long it's amortized for. And most mortgages are amortized for 25 years. That means you pay for them over 25 years and you make monthly payments for 25 years. It takes a long time to pay off a house. So we go here, 25 times 12, you would make 300 payments on your house. By law in Canada, mortgages are only compounded twice per year, whereas other things like car loans are 12 times per year. That doesn't make a huge difference, but it is an advantage for the buyer of the house that it's not compounded as often. We want the future value to be 0, so now we're going to find out how much is it going to cost me a month to buy this house? Can I afford it? Because that's one of the questions you might be asking yourself. Ooh, I want to buy that house. So I go to the payments and I go alpha solve, and I'd have to pay just under $1,000 a month to buy that house. So you might say to yourself, you know what? I think that's worth it because I can afford that. Now what happens with our house? How much did you pay? If you pay $998.54 times 300 payments, you will end up paying $299,000 for your $200,000 house. Whoa. You pay an extra $100,000 for this house. The nice thing about a house, though, is a house is an asset that appreciates, which means that it goes up in value. So probably in 25 years, even though you paid $300,000 for that house, it probably will be worth $300,000 later on. Okay? Now, interest rates right now are really low. They're the lowest, well, they're coming up now a little bit, but in this period of the last 5-10 years, they've been quite low. So you spend when you buy this house, you spend a whole week really researching, working hard to find the best interest rate. And after working really hard, you were able to negotiate and get 3% instead of 3.5%. And your significant other at the time is like, oh my, They didn't take pre-calculus. They're like, oh my, you've spent a whole week and whoa, you saved 0.5%. And you're like, no, it's important. It's really going to make a difference. They're like, really? 0.5%? We could have like cleaned the house in the last week or something like that instead. But no, you were like, got to save 0.5%. Well, let's look. Because now we can go here and say, instead of paying $998 a month, Alpha Solve, we're paying $946. You're like, well, that's a little bit. That's 50 bucks. A whole week for 50 bucks. You're like, but you don't realize that if I take that $50 a whole week, now instead of spending $299,000 for a house, we're spending $284,000. That's $15,000. Right? If I offered you a job for a week, crunching numbers for $15,000, would you be like, okay, yeah, I'll do that. That sounds like a good job. I mean, it doesn't sound like a good job, sorry, but it sounds like a good amount of money. Maybe doing math all week, and you're like, Mr. JR, you're making us do math all week, and you're not paying us anything. But hopefully, this pays you money later on. This is where I'm paying you later on for learning a little bit about this, okay? So you end up spending $283,000 instead of spending $299,000. Now, another interesting thing that happens with people's lives is when you first buy a house, it's when you first have a job. And when you first have a job, it's usually when you're making the least amount of money in your job, because most jobs have incremental pay increases as you go along, or you get promoted, or you get more training, and you get more and more money as you work longer and longer. For my job, in the first 10 years that I taught, every year I got a raise. And then once you hit 10, then it stops. No more raises for me. It's kind of sad. But I got a raise every year. What does that mean? That means you have more money each month that you could put away towards your house. And so,
Could you please have our grade 12 students last name beginning with the letter A through to the letter M? If you
so where we were at with the story is, as you continue in your life, your wages may go up, and all of a sudden you might have more disposable income. And what most people do when they have more disposable income is they buy more things that they like. So instead of having to, make your own supper every night, now we go out for supper twice a week, or something like that, where you're spending more money. But most people just leave their mortgage exactly the same. So where this one was at originally, Alpha Solve, right, we're at 3%, we're at $946. And, it was at $283,000 is how much you paid in this house in total, right? So we started at $299,000. We saved 0.5%, which saved us about $17,000. And now I'm going to say, well, all of a sudden you realize, hey, I think we're making more money, and even though we only have to pay $946, we can afford to pay $1,200. So we can put a little bit extra money away each month towards this. What is that going to do? That's going to shorten how many payments you need to make. So now I can alpha solve my payments, and instead of 300 payments, it saves about 85 payments. 85 payments or 84 payments is roughly 7 years. Okay? So you put a little bit more money away when you started off towards your house, and it's going to save you 7 years off your mortgage. Also, I can now find out, well, how much am I going to pay for my house now? So I already saved $17,000 by knocking off that 0.5% interest. Now if I times this by 215.43, it's down to $258. That's $42,000 off our original amount. So a couple of small decisions ends up saving you a lot of money. And most people decide not to make any of these decisions because they're like, oh, the math is too complicated. And I would say knowing this mathematics can save you $50,000 more than the average person, because you realize, hey, by putting that extra money against my debt, I'm not only spending that extra $200 is like saving me $300. And it's saving me a lot of money. And so over time, that drops it down even more. And maybe a little bit later, you find out I can increase it again. And I can increase the amount.
If we could please have our grade 12 students.
Okay, so that's where we're ending. You can work on questions 3, 6, 7, and 12.